Warm greetings and good morning to everyone. Today we are going to see how the torsion test is performed in the case of torsion testing machine. In the torsion testing machine, which is of capacity 6 kgf meter, so in the torsion testing machine, there is an anchor in the left hand and right hand so that you can fix the specimen, which is of a mild steel material or in the case of a cast iron or composite material. So which is a standard size, which is of 10 mm by 10 mm square size, and which is of 2.5 centimeter and 2.5 centimeter anchorage portion on either side, and the middle portion we have to reduce the diameter as either 5 mm or 6 mm as per the requirement. So the specimen is fixed on the two ends of the anchorage portion, and you have to set as 0 in the angular twist initially. Then you start the motor so that the torque is applied in terms of kgf meter. That will be given the case of dial, so which is a number of graduation and is having a maximum of 6 kgf meter. So due to the torque applied, what will happen? So it is going on increasing increment by increment the torque, and for increment of torque of either 10, 5 kgf centimeter, or 1, 2, 3, 4, 5, 6, up to say 15 to 20 readings you can take. The corresponding torque is achieved in the increment value from 2, 4, 6, 8, 10 like that. You can note down the corresponding value of the uh, angular twist theta in the dial, which is from graduated from 0 to 30 degree on the left side of the machine. So after that, what will happen? So the given specimen is given a torque or twisting moment of a maximum value. So it may be of either 600 kgf into millimeter, or 6000 kgf into millimeter. Before the maximum value of 6 kgf meter, it is going to fail. So at that point, we can take out the specimen from the torsion testing machine. We can see how the shear failure will be happening. So normally, which is of 45 degree in the case of a specimen, not like that of a neck formation in the case of tension testing machine. Then you can measure the diameter of the middle portion. So that will be used in the case of making the shear stress. The torsional equation, pure torsional equation is T by J is equal to Fs max divided by capital R is equal to C theta by L. So where T is the applied torque and J is the polar moment of inertia, and Fs max is the maximum shear stress in the material of the specimen, and capital R is the mean radius of the specimen. Then capital C or capital G is equal to shear modulus of the material of the torsion testing specimen. Theta is the angular twist in terms of radians. You are making theta in terms of torsion testing machine. You have to convert to radians. Theta is always measured in terms of radians finally. L is the length of the given shaft or the specimen what you have taken, which is of either 50 centimeter or 65 centimeter as per the standard size which is given in the IS code. So after that, uh, you can measure the final diameter of the torsion testing specimen failure. You can see the mode of failures and the diameter, and you can use these values in the case of a torsional equation. T by J is equal to Fs max by R. T is the applied torque in terms of Newton meter. Then J is in terms of meter to the power 4 or millimeter to the power 4. So F max, maximum shear stress, or tau max, and our capital R is the mean radius of the shaft, that is capital D by 2, mean diameter by 2. mean diameter is something where the given specimen of the shaft, we can measure 5 to 6 point of the given specimen. You can take the average, that is called as the mean diameter of the shaft or this specimen. Then you can draw the graph between the torque or twisting motion, the y-axis, and the angular twist or theta or pi in terms of degree or radian. You have to draw the graph from 0 to maximum value where the specimen failure. So from that graph also you can find the maximum shear stress, or you can analytically verify by using the equation T by J is equal to F max by R. So F max is equal to T by J into the mean radius capital R. So you know the mean radius is nothing but small d by 2, and torque you can take it from the failure point of the torsion testing machine, and J is the polar moment of inertia for a solid circular specimen, or the shaft is pi d cube by 32. You can take it. So polar moment of inertia is nothing but the moment of inertia of the polar axis. So IP or J. So that will be of pi d power 4 by 32. But in the case of polar modulus, is IP divided by or maximum. That's why pi d per 4 by 32 divided by d by 2, you will get pi dq by 16. That is the polar modulus is at p in terms of millimeter cube. So from that you can find the corresponding maximum shear stress where the testing specimen files, and also you can draw the graph between t and theta. From that graph you can tell various analysis and give the results. This is about the torsion testing machine on a given specimen. It is a standard specimen only we have to use, which is of 10 mm by 10 mm, and at the middle portion you have to use as a diameter, because the shaft would be of solid circular shaft or hollow circular shaft. But in the case of our laboratory, strength laboratory, we have only the we are using the solid shaft. That is the thing. So these are the procedure how to perform the given specimen in the case of torsion testing machine. And the final is to observe the corresponding maximum shear stress and also the torque versus theta value, and also you can find the various T by theta value or the polar moment of inertia is unknown. You can able to find it. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.